So as you can see, the difference quotient is ultimately useful because it tells us the slope of secant lines. And again, just as a reminder, the secant line is basically a line that connects 2 points that are far away from each other. So if you connect these 2 points on a certain graph, then you will be called a secant line. Ultimately, what we want to do is we want to bring the second point closer to the first point. We want to put them so close to each other to where you cannot tell where the first one is and where the second one is. They will be kind of like directly on top of each other. And in that case, the line is going to be something similar to this, and that line is going to be called a tangent line. That's what we ultimately want. We want to know the slope of that tangent line. So that's why we're introducing the difference quotient. And once we know how to find a difference quotient in general, we're going to be taking the formula for the difference quotient and sticking a limit in front of it to find this number over here. So that's where we're headed with this whole discussion ultimately. But before we get there, we have to do a few practices and a few preparations. And so in this next example, it says y is equal to f of x, which is 1 over x, and it wants the difference quotient. So again, the difference quotient is that formula that we described earlier. It's the f of x plus h minus f of x all divided by h. And so again, what is this doing? How is this going to be calculated in this particular problem? So first of all, what does f of x plus h mean? Well, this literally means go to the function f of x and replace all the x's with x plus h's. My function f of x is 1 over x. I'm supposed to replace all the x's in this function with x plus h. When I do that, I get 1 over x plus h. So again, keep in mind, this portion of the problem represents that whole thing right there. Then we have a minus sign. So this minus sign is going to be placed right in the middle. And then we are expected to write down the f of x. Remember, f of x means copy the original equation without making any changes. So this f of x is that part right there. And it's all being divided by h. So at this point, we want to do the algebra to simplify this fraction and turn it into something simple. And in order to do that, I'm going to just stick a 1 underneath here and look at all the denominators. One of them is x plus h, the other one is x, and the other one is 1. And I'm going to decide the LCD is x times x plus h. We did this kind of mathematics when we were doing the review for this class. In the very beginning of the class, we did complex fractions and we divided them, simplified them, and this is how we did the process. So what I'm going to do next is take that LCD that I just discovered and stick it on the numerator of every fraction in my problem. So my fractions are 1 over x plus h, 1 over x, and then h over 1. So I'm going to take the LCD, which was x times x plus h, and stick it on top of every fraction. And the point is, when I do that, things should cancel out nicely. So for example, in the first fraction, some things will cancel out. As a matter of fact, the x plus h and the x plus h are going to cancel. And when they cancel, we're left with 1 times x, which is x. Then we have the big old minus sign in the middle, which we're going to stick again in the middle. And we're going to look at what happens in the second fraction, which parts cancel out. So in that second fraction, the x's are going to cancel out. And we're left with 1 and x plus h. Now on the bottom, nothing actually cancels, so we're left with h, and then we're left with the x and the parentheses x plus h. Okay, so basically that's what we get when we simplify the fraction. Now we still can do some things. For example, on the numerator of this answer, we can multiply things out and maybe hopefully some things will cancel. So we have an x at the beginning, we're going to leave it. We have a negative 1 being multiplied with x, so that's going to give us negative 1x. And then we have negative 1 times h, which is going to give us negative 1h. By the way, the ones don't really matter that much. We can just ignore them. And when we ignore them, we end up with x minus h, all divided by h, then x, then the x plus h. So hopefully you can see that this x and this negative x are like terms, so they're going to cancel. And what I end up with is negative h all divided by h, then x plus h. And by the way, h is repeating on the numerator and the denominator, so we can take it out, remove it. And when we do that, we get negative 1 over x times x plus h. And that will be the final solution for now. So that's the answer. Now, in the next section and the sections that come later on in this chapter, we're going to be asking you to do the derivative. So I'm going to give you a function f of x, and I'm going to say the function is 1 over x, and your job is to tell me the derivative. So how will you find the derivative of f of x? So it turns out that to find the derivative of f of x, you'll have to do all the steps that I just did, but with an extra thing in front. So first of all, the symbol for the derivative is going to be f apostrophe x, and it's going to be a limit as h approaches 0 of the difference quotient. So we're going to do f of x plus h minus f of x all divided by h. So in other terms, you're going to do everything I did on the last example, and you're going to find that this whole answer is just simply negative 1 over x, and then x plus h. And then you're going to stick a limit in front of it as h approaches 0. And what you do now at this point is you notice how h is approaching 0, and you replace h in the problem with the number 0. And once you do that, your solution turns out to be negative 1 over x squared. And that equation, or that answer, is called the derivative of the function f of x. That's the reason why we're discussing this whole difference quotient business. And that derivative is supposed to be a super powerful tool in mathematics. It can tell you a lot of information about the function itself, about all kinds of different things and all kinds of different applications. It's useful to people who are doing engineering, math, physics, chemistry, biology, economics, business, whatever. It's useful in all kinds of fields of science. So that's the reason why we're doing all these difference quotient steps, so that when you have to stick a limit in front of it, it'll be easy and you'll know what to do basically.